Okay. So, the way that your book does things is a little bit different than the way I do things. They differentiate between a plus b squared and a minus b squared, and I'm not going to differentiate between those two. Okay, so if we take a look, let's get started. If I do a plus b squared, I could also write that as a plus b times a plus b. And if I were to FOIL that out, sure, thank you. Tyrus?
Yeah, he's here.
No. What do you think?
Grant Walker dismissed.
15. Cool. 20, 24. All right. So if I do a plus b times a plus b, I just FOIL that out. I get a squared plus a times b. Take it easy, Grant.
See you, Grant.
Plus b times a, or just a times b, plus b squared. And you might notice that these two terms are the same. So they become a squared plus 2ab plus b squared. You see? Now, did I tell you anything about a or b? Could they be numbers?
Yes.
Could they be positive numbers? Yeah. Could they be negative numbers? Yeah. Could they be variables? Class? Yeah. Could they be numbers and variables? Yeah, sure could. So it doesn't matter what a or b is, it will always follow this form. And what is this form? Well, I square the first. See that? I square the last. And then I multiply the two terms. Multiply and double. So I square the first, square the last, multiply and double. See that? Okay. Square the first, square the last, multiply and double. Just like that. Okay? So what's an example of that? Well, an example of that is x plus 2 squared. All right? Well, I'll square the first, x squared, square the last, 2 squared, multiply and double. So I do 2, that's the doubling part, times x times 2. Simple as that. So you see I'm multiplying my two terms and then doubling them. Becomes x squared plus 2 times 2 is 4. X plus 2 squared is 4. You see that? Pretty clear? Square the first, square the last, multiply, and double. So, okay. Everybody do x plus 3 squared now. Okay. I square the first, so it's x squared. Square the last, so it's 3 squared. Then multiply and double, so that's the doubling. Then I multiply together x times 3. And I get x squared plus 2 times 3 is 6x plus 3 squared is 9. You guys see that? Any questions about this? See, square the first, square the last, multiply and double. Simple as that. You can still FOIL it, yeah, but it just takes more time, you know? It just takes more time, really. So let's do another one. Here, I'll put that back up for a second in case anyone was copying. All right, let's do another one. X minus 3 squared. I'll do this one with you. Square the first, square the last. Well, it's not just 3, it's negative 3 this time, you see? Then multiply and double. So plus 2 times x times negative 3 equals x squared. Positive times a negative is negative. 2 times 3 is 6x plus negative 3 squared is 9. What happens when I square a negative number? It becomes positive. Very good. So x squared minus 6x plus 9. Okay, now I'll give you one to do. X minus 5 squared. Go ahead and do that one on your own. Okay. Square the first, square the last, negative 5 squared, multiply and double. So that's the doubling. 2 times x times negative 5 equals x squared. Positive times negative is negative. 2 times 5 is 10. X plus negative 5 squared is positive 25. You guys got this? Understanding it? Yes, sir.
If we do it the FOIL way on the test, will we get points off?
You won't get points off, but here's the thing. Like, I want you guys to use this, okay? So if you do the FOIL method and you make a mistake, you'll definitely be penalized harder than if I want you to do this. Does that make sense? Like, if you do the FOIL method and you make a mistake, you're going to lose a lot more points than if you use this method and make a mistake. Not because I think the foiling method is wrong, it's just the whole point of this is to give you guys, like, an understanding so you can do it faster every time, okay? And I'll be honest, if I ever see something like this, like in my whatever, if I'm writing a math problem or I'm checking math homeworks or something, whatever it is, if I'm ever doing something like this where I'm squaring a binomial, I always use this method. I never FOIL it out. To me, foiling seems like a waste of time. You understand? So I might not be the perfect example of how to do math, but I've been doing it for some time and I obviously want to save time and do it the best way. And I really recommend that you use this method. Does that make sense? Okay, and I believe in the long run it does become easier to understand. You just need practice. Okay, all right. So next one is negative x minus 4 squared. So go ahead and do that one. Negative x minus 4 squared. Okay, square the first, so negative x squared. Square the last, negative 4 squared. Multiply and double, so plus 2 times negative x times negative 4 equals negative x squared just becomes x squared. Positive times a negative, well, a negative times a negative is a positive, so it's plus 2 times 4 is 8x plus negative 4 squared is 16. See? So look, that last term and that first term will always be positive. It's only the middle term that could either be positive or negative, you see? Just the middle term that can be positive or negative. Any questions on this? Just like everything else, it takes practice, and you'll be able to get it strongly. Okay, next one. 3 plus x squared. Go ahead and do that one. Do it fully. All right. Square the first, square the last, multiply and double. 2 times 3 times x. 3 squared is 9, plus 2 times 3 is 6x, plus x squared. Am I done? Am I done? No. What do I have to do? Write it in standard form. Very good. Put them in order. X squared plus 6x plus 9. Now I'm done. Okay? Always want to write it in standard form. All right. Now let's kick it up a notch. All right. If I do 4x, just to kind of give us a precursor, if I do 4x squared, what do I do with this exponent? I distribute it, right? I distribute it to both of those terms. And I get 4 squared times x squared equals 16x squared, right? Okay, so 3x plus 2 squared. Go ahead and do that one now on your own. Three x plus 2 squared. Okay, I square the first, square the last, multiply and double, so 2 times 3x times 2. This square term, this exponent, needs to be distributed into the 3 and the x, so it becomes 3 squared, which is 9, x squared, plus 2 times 3 is 6, times 2 is 12, x, plus 2 squared is 4. You guys see? Yeah? Okay. All right. Any questions on this one? Okay, you guys are just rocking out over here. It's like guitar solo all day. All right? All right. Now, what about this? What about if I say x to the third and then I square it? What do I do with those exponents? I multiply them. It becomes x to the 3 times 2, which is x to the 6th, right? And what about if I have like x to the 3 times x to the 2? Atom. So that's x to the 3 plus 2 equals x to the 5th. Yep.
What if it were x to the third plus x to the second?
Then they just stay separate because they're different terms.
Oh yeah, I got you.
Good question. All right. So now x to the third plus x squared. Go ahead and do that on your own. X to the third plus x, square the whole thing. Square the first, square the last, multiply and double. Square the first, square the last, multiply and double. Okay, let's give this a try. So I square the first, square the last, multiply and double. So 2 times x to the third times x. Well, x to the third squared, well, that's exactly what we did before, is x to the 6 plus 2. X to the third times x to the first is x to the fourth plus x squared. Is that in standard form? Yeah, it is. As long as the highest degree term is first, and then it's in descending order, right? So, simple as that. Okay, you guys got that? You notice how I didn't make any distinction between whether it's positive or negative or anything like that? Like the book kind of makes that distinction, but I think it's confusing to make that distinction, so I just did it this way. So just square the first, square the last, multiply and double. Make sure if it's negative, it's in parentheses. Right? Questions, Mr. Sanchez? Okay, so obviously it's going to take practice to get really good at this, but we have one more thing. All right? One more thing. Any questions before I move forward? Okay. So what about a plus b times a minus b? Well, these two are called conjugates. Why are they called conjugates, Mr. Munir? Well, they're called conjugates because they have the same exact terms, a and b, but one is positive and one is negative in the middle. Does that make sense? Oh, no. No, I think that's Mrs. Hendricks. So, go ahead, sir. So a plus b times a minus b. All right. Those are conjugates because the terms are the same, but one is plus in the middle and one is minus in the middle. You see? If the terms are any different, like if it was a plus b times a minus c, then they're not conjugates, and you don't do this. It's only if the terms are the same. Well, if the terms are the same, well, let's FOIL it and see what happens. I'd get a squared minus, because positive times a negative, so minus ab plus ba, or ab, and then plus positive times a negative is negative b squared. What happens to these two middle terms? They cancel, right? So it ends up as a squared minus b squared. Did I say anything about a or b? Give any qualifications about what they may or may not be? No, right? So therefore, I know that they can be anything. Positive numbers, negative numbers, variables, doesn't matter. Got it? So a and b can be anything. So let's give an example of this. X plus 3 times x minus 3. All right, well, what do? I square the first and then subtract and square the last. So it's really simple. It's just x squared minus 3 squared, or x squared minus 9. You see how now it's like, should I FOIL? No way. When you have these conjugates, it's like super fast, right? In this case, it's obvious. Okay? So go ahead and, after you copy that one down, do this one on your own. X plus 5 times x minus 5. Okay, pretty straightforward. Square the first, subtract, square the second. X squared minus 25. Got it? Yeah? All right. Last one. 2x minus y squared times 2x plus y squared. Okay, if you can do this one, you should be pretty solid on basically all of this. Square the first, subtract, square the last. Square minus square. All right. Square the first minus square the last. That square gets distributed to the 2 and the x. 4x squared minus y squared to the second power, y to the fourth. I multiply the two powers, 2 times 2. And that's it. Final answer. Yep.
Because for me, I can boil it half the time I can do that, and that's confusing me. Like, a lot.
Okay. Here's what I will say. Same thing. If I put this on a test and you don't remember this specific thing, you can always revert to foiling. But if you foil and you make a mistake, it's going to be harsher penalty than if you do this method and make a mistake. Okay? The reason why is exactly like I explained before. At the end of the day, if you practice this and you get good at it, like on your homework, I don't want you foiling on your homework. Practice this on your homework. Do you understand? Practice this method on your homework. Okay? And maybe you'll find by the end of the practice, oh wait, actually this is easier. I'm not confused anymore. It's simple. It's the first time you're seeing it. So it makes sense. You might be like, this feels a little shaky. But if you practice in your homework, it might be a lot easier. Okay? And also remember that they're not all going to be that challenging. That was just a harder one. If I have x minus 3 times x plus 3, oh, those are conjugates. That's just x squared minus 9. I'm done. You see? I don't even have to write out the step. I know 3 squared is 9. So I'm just done like that, you see? So that's, you understand? So it's like when you get good at it and it's a simple one like that, it's like, yeah, obviously you just use the trick. It's kind of like a trick in a sense, but it's not. It's a special product. Okay? All right? But good questions. It's good to push back sometimes and be like, hey, this doesn't seem right. It's good. All right. So let's continue on with a modeling question on the near the top of page 193. We have another question about a garden. And we'll do this one together. I'll give you about 20 seconds just to read that over. So go ahead and read over number 13, please. Page 193. Okay. Square patio has a side length of x minus 3 feet. It is surrounded by a flower garden with a uniform width. Side length of the entire square area, including the patio and the flower garden, is x plus 3 feet. Write an expression for the area of the flower garden. All right. So a square patio has a side length of x minus 3 feet. What should I draw?
A square.
Square. Draw a square. Okay, and its side lengths are x minus 3 feet. Okay, and it's surrounded by a garden of uniform width. And the side length of the entire square area, including the patio and the flower garden, is x plus 3 feet. So that's this whole thing here. All right, and just to make it clear, we can shade in the area of our flower garden. Draw some flowers. Nice. Have some fun. You know, we got a little bluebird in our garden. You know, he's hanging out. It's just like hanging out, you know, fluttering around in the flowers, just like chilling, having a good day, you know. All right, so there you go. So here's our patio surrounded by our garden. Cool. And now it says, write an expression for the area of the flower garden. Well, if the garden was this whole square, then it'd be easy. The area would just be x plus 3 squared, right? But it's not the whole square. It's almost like it's this square, but this inner square taken away, right? So take away in math terms is what? Subtractions, right? So we have this bigger area, and we what? This smaller area from it. Subtract. So we have the bigger area, and we subtract the smaller area from that. So if we say that, for instance, the area of the garden equals the area of the outer square minus the area of the inner square, we can get our solution, right? And then we just need to come up with what the area of the outer square and the area of the inner square are, and we can plug it into this equation here, right? Does that make sense to you guys? Okay, so the area of the outer square is equal to x plus 3 squared, right? And if I do this out, I square the first, square the last, which is just 9, multiply and double. 3 times x is 3x, and I double that is 6x. Okay? So that's the outer square, is x squared plus 6x plus 9. And then I do the inner square. And the area of the inner square is just x minus 3 times x minus 3, or x minus 3 squared. And again, I square the first, square the last. Negative 3 squared is still positive 9. Multiply, negative 3 times x is negative 3x. Double is negative 6x. See? All right. Now I just take these and I plug them into my equation here. And I get the area of the garden equals the area of the outer square, or x squared plus 6x plus 9, minus the area of the inner square, which is x squared minus 6x plus 9. And now, hey, look, I'm subtracting polynomials. Remember that? Lesson 4.2? Okay, it's a great question. X squared plus 6x plus 9. What do I do with this minus sign? Distribute it in. Very good. Minus x squared minus a negative is plus 6x. minus positive is minus 9. And then I go ahead and I look and I say, well, x squared minus x squared, well, those cancel out. 9 minus 9, well, those cancel out. And I end up with the area of the garden equals 6x plus another 6x is 12x. And that is my final answer. Does that make sense? Any questions on that, guys? Okay, good job hanging in there right up to the last minute. Well, we have 10 minutes left. Homework. Homework is page 194, numbers 1 through 20. Okay, so number 194, numbers 1 through 20. Okay, page 194, might as well get started on it now. You got 10 minutes left of class. 194, numbers, bathroom. Yeah, just go. Yeah? Yeah, go ahead. You can go too. You only got 10 minutes left. 194, numbers 1 through 20. That's the homework. All right. Good job, guys.